Okay, we are back to decimals. We are comparing decimals. Okay, we're starting over here. We have the ones place to the left of the decimal, ones, tens, and to the right of our decimal, we have numbers that are less than 1. We have tenths, hundredths, and thousandths. Remember, all of our decimal place values end with a THS. So don't confuse the tens with the tenths or the hundreds with the hundredths or the thousands with the thousandths. So let's say a couple numbers real quick. 1 and 5 hundredths. The decimal always says and. How about this number? 1 and 52 thousandths. Okay, so let's look at these grids here. So to represent the tenths, we have a tenths grid. To represent, back to the tenths. So to represent the tenths, we use this tenths grid. It has 10 longs. To represent the hundredths, we have the hundredths grid, and that has 100 baby cubes. The thousandths grid is a little crazy. To represent the thousandths grid, to represent the thousandths, we have this grid right here. And yes, it has 1,000 tiny little sliver pieces. So they're all the same size. They're all one whole. If they were shaded in, this represents tenths, hundredths, and thousandths. The thing is that we can choose any of those grids to represent equivalent or the same values. Check this out. I have 3 tenths. If I wanted to split those 3 longs up into baby cubes, each long is 10 baby cubes. We know that. So I could take my 3 longs, break them apart, and have 30 baby cubes. So 3 tenths is exactly the same value as 30 hundredths. If you wanted to take your 3 tenths and break it up, which would be so hard, into little tiny sliver thousandths, then you would get 300 the thousandths. So 3 tenths, 30 hundredths, and 300 thousandths is equivalent. And notice the pattern. The 3 always stays in the tenths place. I'm just simply adding zeros to show you that each of the tenths has been broken into 10 pieces. All right, 5 tenths is equivalent to 50 hundredths and 500 thousandths. Again, I have my 5 tenths in the tenths place every time. But when I switch to hundredths, I add a 0, and when I switch to the equivalent thousandths, I add an additional 0. So remember that when we compare decimals. Okay. Let's say somebody wants me to compare 6 and 2 tenths with 6 and 21 hundredths. So we're going to start comparing all the way to the left first. We're looking at the largest place value first. My largest place value is the ones place. It's a tie. They're both 6s. So there's nothing I can do with that. It's a tie. Now move to the right. They're both 2 tenths. It's still a tie. So this is 2 tenths and this is hundredths. It's very hard to compare tenths to hundredths. So I want to change my 2 tenths to an equivalent hundredths. How can I do that? Well, if I had 2 longs, it would be the same as 20 baby cubes. So I add my 0. And yes, you do need to do that. So I added a 0 and I changed my 2/10 to 20 hundredths. Now it's an even battle. I can do tenths versus tenths, but I can't do tenths versus hundredths. I want to make them both hundredths. You can't compare apples to oranges. So what's bigger, 6 and 20 hundredths or 6 and 21 hundredths? 6 and 21 hundredths. So 6 and 2/10 is less than 6 and 21 hundredths. Let's look at the next one. This is a fair battle. I got 2 and 1/10 versus 2 and 5/10. All right, I got a tie in my ones place. I move over. I have 1/10 versus 5/10. That's easy. 5/10 is greater. So 2 and 1/10 is less than 2 and 5/10. Uh-oh, this is an unfair battle. I have a tenths versus a hundredths. All right, a tie. I'm moving over. I want to change my tenths to hundredths. It's just not fair. So 1/10, 1 long, is the same as 10 baby cubes, or 10 hundredths. Add that 0. Now it's a fair battle. Uh-oh. So 2, sometimes I like to stack them. Stack them up. Then you could really see which one's bigger. All right, it's a tie. 8 is larger than 0. Therefore, 2 and 18 hundredths is greater than the 2 and 1/10. So every time, same amount of digits to the right, same amount of digits to the right of the decimal. Uh-oh. Here I have hundredths. Here I have thousands. That's not a fair battle. I can't compare. 30 hundredths is the same as 300 thousandths. Oh, they try to trick me. Equivalent. So if you do not have the same amount of digits to the right of the decimal, you simply add a 0 to even them out before you compare. What if they gave me, quite a few numbers, and they wanted me to round these numbers? You know what? We're not going to round them. They wanted me to compare them. Maybe they wanted me to put them in order from smallest to largest, or largest to smallest. This is the easy one right here. 62 hundredths versus 7/10. I'm not comparing hundredths to tenths. It's not fair. I need to make them the same. So what should I do? 7/10 is 7 longs, which is the same as 70 baby cubes. I add a 0, and then I compare. Oh, right off the bat, the 7's larger. All right, now here's the situation. Let's put these in order from smallest to largest, but it's not a fair playing ground. I'm dealing with some tenths, some hundredths, and even some thousands. This is crazy. I can't even focus. All right, I need to stack them up, line up the decimal. I can compare my tenths if they're all lined up. Hundredths. I need to add a 0 here. 9/10 is equivalent to 90 hundredths. But it's still not an equal playing ground because now I have hundredths versus thousandths. All right, let's make all of our numbers have the same amount of digits to the right of the decimal. Now I'm comparing all thousandths. Real easy. So we're going to line them up, line them up. Okay. Start all the way to the left with the largest place value. 9, 6, 3, 4, and 9. Smallest to largest. Here is my smallest. Cross that off. What's the next smallest tenths? 469 thousandths. Cross it off. 9, 6, and 9. 6 is the next in order from smallest to largest. All right, then I have a tie. 2 9s. So let's see. Go next door and we'll compare the hundredths. What's bigger, 8 hundredths or 0 hundredths? The 8. So that is the largest number. So I'm going to put up my 9 tenths, and the next will be 980 thousandths. So whenever I'm comparing numbers, first off, I need to make sure that they're all in the same format. Either all tenths, all hundredths, or all thousandths. And if they're not, I'm going to start adding zeros to even them out. Make sure I have the same amount of digits to the right of the decimal each time. Then I'm going to stack them up to compare them, starting with the largest place value and then moving to the right one at a time. And obviously, I'm always keeping track of what I'm doing by crossing things off and taking notes.